All right, so we're back with three variable systems, and I wanted to go over another example with you guys because three variable systems do require a little bit of work. I should say a lot of work. They require quite a bit of work, and they do take some getting used to. So I want to go over with another example with you guys. And remember, it's extremely important. It's extremely important that we make sure that we're being very careful with all of our steps and that we're staying organized. Because if you make one little mistake, boom, your whole problem's blown up. You're not going to get the right answer. So let's go ahead and take a look at this system here, okay? Now, just like with the previous problem, I'm going to go ahead and solve this using elimination, all right? Now, once again, with elimination, what you want to do is you want to pick a variable that you kind of want to pick on, I guess, and you want to eliminate that variable twice using two different sets of equations, okay? So in this particular case, I'm going to go ahead and pick on x. I'm going to cancel out x, all right? So the easiest equation to work with is definitely the third one. So I'm going to use the third one and the first one for our first case, okay? And if I add these two equations as they were, nothing's going to cancel out. So I need to go ahead and I need to multiply this equation here by -2, okay? I'm going to multiply this equation by -2. So I'm going to rewrite the first equation so we can stay organized. And I'm going to go ahead and multiply this second equation by -2 because now I'm going to have -2x minus 2y minus 2z is equal to -10, okay? And now when I add these two equations together, I'm going to have a new equation, all right? So this is going to be an equation that I'm going to want to work with. So 2x minus 2x, well, that cancels out. That gets me 0. That's what I want. -2y minus 2y is a -4y. And -5z minus 2z is -7z is equal to -5 minus 10 is -15. So this is going to be an equation that I'm going to want to work with, okay? This is an equation I'm going to want to work with, all right? So I went ahead and I multiplied that third equation by -2 so I can use the first and third and cancel out the x's. Now I can't use that combination anymore, but the third equation is very nice to work with, so I'm going to go ahead and actually use that third equation again. But in this time, I'm actually going to multiply it by a +6. Oops, I'm going to multiply this by a +6 because now if I use the second and third equation, I have a -6 up here. I'm going to want a +6 down here. So I'm going to multiply this entire equation through by +6. All right, so I'm going to rewrite the second equation, -6x minus 6y minus 3z is equal to -27, and I'm going to multiply through that +6 into the third equation. So that's going to be 6x plus 6y plus 6z is equal to 30, okay? And now I'm going to go ahead, I'm going to add these two equations together, okay? So -6x plus 6x, that cancels out. That's what we wanted, okay? But this is actually kind of a nice thing that happened right here. -6y plus 6y is also 0, so that cancels out as well. -3z plus 6z is a +3z. -27 plus 30 is a +3. So in this case, not only did our x's cancel out, we wanted that to happen. The y's actually canceled out too. And that makes our problem a whole lot easier because now I would have had to go on through a whole extra set of systems and canceling out using elimination or substitution. But now, since that actually both canceled out, now I have 3z equals 3. I can quickly solve for z now by dividing each side by 3 to get z is equal to 1. So now I know z is equal to 1. Now I can go ahead and actually use this and substitute it into this equation right here. I can substitute in this equation right here to quickly solve for y. So this is actually a nicer case. This was a problem that actually worked out fairly nice. So now, since I just inadvertently got z isolated by itself and solved for it, I can now go ahead and substitute in 1 for z in this equation right here and solve for y. So this is going to be -4y minus 7z. Well, I actually just found that z is equal to 1. So I'm going to substitute in 1 there is equal to -15. And now I'm going to get -4y minus 7 is equal to -15. I'm going to want to add 7 to each side to get -4y is equal to -8. And now that -4 is multiplying y, so I can divide each side by -4 to get y is equal to 2. So now I have y is 2, I have z is 1, and now I can go ahead and I can substitute these into any equation, any original equation, and solve for only variable that we don't know yet, which is x. And I'm actually going to once again use that third equation because there's no coefficients on x, y, or z. That's why it was such a nice equation to work with. So I'm going to go ahead and kind of pick on that third equation. So I'm going to go ahead and take, let's use this color. I know z is 1, so I'm going to take that, substitute it in for z here. I know y is 2, so I'm going to take that, substitute it in here, and now I'm just going to have x to work with. So I'm going to have x plus y, which is 2, plus z, which is 1, is equal to 5. Okay, and that's going to become x plus 3 is equal to 5, and you subtract 3 from each side to get x is 2. So our final answer is going to be 2, 2, 1, and that right there will be our final answer. Okay, so that was another example of 3 variable systems. I'll go ahead and make a video about the application of 3 variable systems, so we're going to go through a word problem or two. Go ahead and check that out next. Alright, but this was solving 3 variable systems. Make sure that we're practicing, make sure that we're staying extremely organized with this.